Okay, so we're going to be looking at solving systems by substitution and by elimination. Okay? So just the two algebraic methods of solving systems. Okay? Main thing you guys want to be thinking about is, in the end, for the most part, you guys will be allowed to pick what method you want to use. Okay, we're going to do a couple of substitution problems, and then I think the first two homework problems say use substitution, and we're going to do a couple elimination problems, and I believe the next two homework problems say use elimination. But after that, it's use what method you want. Okay, and so we want to talk about why would you use one method versus the other. What do you want to see from the system in order to say, okay, I should use this method versus the other. And in the end, any method will work. It's just about trying to do the problem in the easiest way. Okay, so it's kind of keeping that in mind. What's the easiest thing I could do? The least mistakes I can make, the least amount of work I could do to solve this. Okay, that should be our goal. Knowing that any method will work, what's the easiest way through this? So, for substitution, what do we want to see? Right? What's going to be telling us that we should use substitution versus elimination? What we want is for one of the equations to have a variable that's isolated. Okay? For it to say x equals, or for it to say y equals. That's what we want. If we don't have that and we can get it to happen easily, then we might use substitution. Okay? And so when you go to look at what problem and say, what variable should I isolate? Because you have four choices, right? There's four variables there. Which variable should I isolate? What you want to do is key in on anything that has a coefficient of 1. That's going to be the easiest variable to get by itself. If there's only one of those. If there's multiple ones that have 1s, then you kind of get a pick. But here we only have one variable that has a coefficient 1, so that really should be the one that you key in on. Yeah, if you want to write down, Peyton, again, I think once we do this, you'll know them pretty well. You should remember this. So if you want to write down the steps, you certainly can. And I think these are definitely a little bit more wordy than I normally would have. I would have worded them, but. Yeah, if you need to write down steps, you can. I can always send this stuff to you guys too, or you can write it down later. Okay. But I want to get that x by itself because it's going to be the simplest. Because to get any of the other variables by themselves, I would end up having to divide by something in order to do that. So, and division is going to create fractions. Fractions are going to create messes. So it's not that it's undoable; it's just messier. Right? Not as easy. So key in on any coefficients of 1. And say, okay, well, let's get x by itself here. So of course, to get x by itself, we would subtract the 3y over. So you could say x equals 3 minus 3y. You could say x equals negative 3y plus 3. Doesn't matter which one you use. Just make sure you have the signs correct. I'm going to use the first one. So we've got one of the variables isolated. So we do is a substitute, right? Well, that's called substitution method. Substitute that expression into the other equation. You have to make sure you put it back into the other equation. It cannot go back into the same one you just used. So that is x, right? So that's going to go where the x was. It's going to substitute out the x. We have 2 times something plus 5y equals negative 5. That something being 3 minus 3y. So at this point, you should have one equation with only one variable. Right? This just has y's in it now instead of having x's and y's. Pretty common mistake is people will leave that x here just hanging out. Right? That's not substitution. That's like putting something next to something else. That's not what substitution is. It needs to be completely replaced. Right? It'd be weird if there was a substitute teacher here and I was here. Okay? So when you substitute out that x, that y all that needs to go in its place. And from here, it's just solving, right? Really simple solving stuff. Linear equations, a little bit of distribution. 6 minus 6y plus 5y is -5. Got some like terms to combine there. -6 plus 5 would be -1, so -y. And get y by itself, so I'm going to subtract 6. -5 and -6 give me -11. So if -y is -11, then positive y must be +11. Or divide both sides by -1, multiply both sides by -1, whatever. There's our y value. So there we've gotten through step 3. I would solve for that remaining variable. Again, this should be pretty straightforward Algebra 1 stuff for you guys. Okay. I'm going to substitute that answer back into one of the original equations. Doesn't matter which one you use. From step up here, make sure you do it in the original equation. Generally, I would just look to see which one has the smallest coefficients. So I see that second one has smaller coefficients. So I'm going to use that one instead of that one. Again, it's just all about ease, nothing else. Using this equation to find x. So subtracting 33 over, give me -30. So just like on Friday, I want you guys to write your answers as ordered pairs. Okay, so -30, 11 will be what we think is our answer. And then, of course, you always want to check back in both equations. Okay, you do need to use both when you do your checks, just like on Friday. Make sure it works. And you guys shouldn't get any weird numbers here, only integers. We made sure we picked clean problems. So if you do get a decimal at some point and you made some mistake, try to go back and fix it. And if your checks aren't working, then either your check is messed up or you've messed up your answer. So there's no extraneous answers with these types of problems. So 2 times -30, 5 times 11, So make sure when you do your checks, you remember it's just simplifying. You don't move anything across the equal sign. So it's -60 plus 55. -60 plus 55 is -5. Works there. It's -30 plus 33, which is 3. 3 equals 3. So it worked in both equations. What we're trying to do is find that point where the lines cross. Okay? These two lines are meeting somewhere. Again, we're only doing linear stuff here, not doing anything, no curves or anything like we saw on Friday. So it should be much simpler. The checks should be much simpler than what you guys were doing on some of those on Friday. So if I'm asking you guys questions, make sure you're being like specific, because there are 2 x's, there are 2 y's, like which x, which y you're looking at when you're responding. So we want to use substitution to solve this second system. Which variable should we isolate? What would be the easiest? Can't say top one, Peyton, because you're going to be more specific. Top what? top x, top y. You need to pick one variable to isolate. Just think of it. Second. What are you trying to do? What's your goal? Get that y by itself? Okay, yeah. Yeah, definitely would look at that and get that y by itself would be the easiest by far. So yeah, add 2x to both sides. Key in on that 1 there. So again, you can say that's 2x plus 4. You can say that's 4 plus 2x. Does not matter. Just make sure the signs are correct, right? It's a positive 2, it's a positive 4. Right? It doesn't matter what order they're written in for this type of thing. So whichever one's easier for you. Tatum, what should we do with that now? Where? Okay. So plug it into the y in the other equation. So 3x plus 2 times 4 plus 2x. Make sure you have one equation with one variable, right? There should be no more y's at this point because we've substituted the y out. And if you still have 2 variables, then you're not doing yourself any good, not progressing the problem. Okay. Natalie, what's the next step? Okay, so what do I get? Okay. Jacob, what's next? What's next? Okay, what do we got? Okay, what would that give us? Jacob's kind of doing 2 steps at once, combining like terms and moving something. What's that give us, Jacob? Hmm?
7.
Okay. So x must be -1, right? Divided by 7 on both sides. Cool. Connor, what should we do with that -1? Don't need to do both. Just need to do one when we're solving. Connor wants to plug it into the top one, so 3 times -1 plus 2y equals 1. So I probably would have done the second one because we're trying to find y now, and y is a little bit more alone here. Again, it's not that there's anything wrong with it, it's just kind of that ease thing. So I probably would have identified that there's no coefficient here, but so adding 3 to y equals 4, so y must be 2. I think -1, 2 is the answer. Yeah, so when you're solving, you just need to do one, right? So it's just that into either equation. Right? Then we go to check, and you do both. So 3 times -1 plus 2 times 2. -3 plus 4 is 1. 1 equals 1. Check. And then it's 2 plus 2, which is 4. good. Anything about substitution method you guys have questions about? Subject?
So I put x equals negative one on the equation. And I got
You got y equals what?
I got y.
1? Okay, so you did -2 times -1 plus y equals 4. What's -2 times -1?
3. Negative 72.
There. Right. So yeah, so when you went to check that, now the one should work, right? And so Jake had just done a little math error here as he was solving for y. So you get -1, 3 or whatever you had, or 1. You go back and check, and your checks aren't going to work. All right. So if your checks don't work, you either mess up your check or you messed up your solving. I would start with checking my checks again, just to make sure it wasn't some arithmetic error, because that's going to be the least amount of work to fix would be down in here. But then if you find out that you didn't do this math wrong, and it's still not working, then you have to go back and I would start here, make sure you track through here correctly. Then if that's looking good, then you have to go back to this part and say what's wrong here. Your answers should work, right? There's no extraneous answers with these. All right, so elimination. Generally, people like this method a little bit more. It tends to be a little bit faster, but again, some problems are set up to be substitution, some problems are set up to be elimination, some problems you kind of pick. So again, always just trying to figure out the easiest way to go through these is the best thing, guys. But at any moment, they both should work. What would be the easiest? So with substitution, we want one of the variables to be by itself, right? That's what we want, or we need to get that. With elimination, what we want is one set of variables to have opposite coefficients. Okay. So when we say opposite coefficients, what we're saying, is like that I have a 6x and then a -6x. And those have opposite coefficients. So what we do is we add the equations together, and if we add those together, they'll cancel to be 0, so we'll have no x's left. So then we'd have some combination of y's. Okay? So this is what we want, one set of variables to have opposite coefficients. So whereas on the substitution method, we look at just one variable, how can we get one variable by itself? Here we need to look at both x's or both y's and say, how can I get them to be opposites of each other? Okay? We do need the equations to be in the same form for this to happen. So if you look at this first problem here, notice how the equations are not in the same form. The x and the y are on the same side here. The x and y are not on the same side here. So when it says line up the equations, that's what it means. Just get them in the same form. And generally you want it in standard form where x and y are on the same side. Mathematically, it doesn't matter, but this is generally the easiest for our eyes to deal with, is when they look like this, versus having, I could very well just move that y over and they'd be in the same form, but that's generally it's easiest for us to see when it looks like that. So the first thing I need to do is fix that second equation in number 3. That's going to bring that y over. So x minus y equals 10, and 2x plus y equals 8. And by doing that, we actually set up the problem perfectly, because what we want is opposite coefficients. And so right here, we have a positive 1 and we have a negative 1. So there's our opposite coefficients. So when we go to add those equations together, okay, that variable will eliminate. So just add straight down. Of course, 2x plus x is 3x. Those cancel. And 8 plus 10 is 18. Of course, we'll just divide by 3. X equals 6. So generally this method tends to be a little bit faster, which I think is part of the reason too why people like it. Like we found x already versus looking at the amount of work it took us to find the first variable here. Generally more work with substitution. So I think it's part of the reason why people like the elimination method a little better. It's faster. Most of the time. So there's x. And just like before, we need to plug it back into one of the equations to find y. As I look at this, it says x equals, I have to do a little bit of solving. By the way, I have to do a little bit of solving. The y's, there's not much around them, so it's kind of doesn't really matter which one you use. I'm just going to use the second one. So I got y equals -4. Let's check those real quick. 2 times 6 plus 4 is 8. So 12 minus 4 is 8. Checks out. And -4 plus 10 is 6. So that was a very easy elimination problem. It was, we just had to do one little thing, and it was ready to eliminate. We see in the next one, it's already set up. X's and Y's are on the same side, but we don't have that kind of gimme opposite coefficients, right? Here I have 5 and 2, those aren't opposites. Here I have 3 and -4, and those are not opposites. So you guys need to be thinking about is, we've been talking about LCDs recently. These are not denominators, but you want to think about LCMs, least common multiples. What are the smallest number that 5 and 2 both go into, or what's the smallest number that 3 and 4 both go into? Okay? So you need to be thinking about, which of those would be easiest, right? There's nothing that I can multiply 2 by to get directly to 5, right? Or nothing easy, like no integer. Right? There's nothing I can multiply 3 by to get 4. Okay? But I can multiply 3 and 4 both by something to get 12, right? Or I can multiply 5 and 2 both by something to get 10. Right? So there are, relatively small common multiples for them, right? So do I want to make 10s or do I want to make 12s? Not really a big difference. If I had to make 10s versus making 30s, then maybe I want to do the smaller one there. Now, there is one advantage to one of these sets versus the other. You notice that here these are both positive. So in order to get a negative out of one of them, I would have to multiply through by a negative. There's higher chance if you're multiplying through by a negative that you're going to make a mistake as you do that distribution. Okay? Whereas here, these are already opposites sign-wise. So if I just multiply this by +4, I multiply that by +3, signs are already opposites. So there's less likelihood you'll make a mistake multiplying by a positive than by a negative. So I would just suggest that if you guys have that opportunity to take advantage of it. But in the end, the numbers don't care which one you do. It's more about you, right? What's easiest. So I would just suggest that multiplying by positives is going to be easier than multiplying by negatives. So we're looking at those there to say, how can I get them to be the same number? 12 is the number we want them to be. Okay? Multiply that top equation by 4. Multiply that bottom equation by 3. So make sure you're doing your distribution. Okay? If you mess up the distribution, of course, that's going to mess up the problem. So I get 20x plus 12y equals 8. And 6x minus 12y equals -60. At that point, we should be able to add down because those y's will cancel. Those y's will eliminate. Say again, Jet?
You don't always have to do that.
Do what? No, certainly don't always have to do it. Generally, there will be some sort of multiplication that you need to do. Either one equation or both equations will need to be multiplied by something in order to make them opposites. So Joe was asking if we always need to multiply. Yeah, it's definitely not always. This would be on the higher end of an elimination problem where you have to do both multiplications. So on the first one, we didn't do any multiplications. You might just have to multiply one. If this was a 2 and that was a 6, right? We just need to multiply by 3 to get those to be opposites. Or -3 or something like that. You might need to multiply both. That'd be -52. Thankfully, when you divide that out, it gets to -2. And any decimals, if you hit a decimal fraction, you've made a mistake somewhere. And we're only giving you guys problems that work through cleanly. And then plug it back in. Again, kind of just figure out which one you want to do. I'm going to use the first equation. Yep. Yeah, always plug it back into the original. So adding 10 to both sides, 3y equals 12. So y must be 4. So -2, 4. I mean, just in like writing, that was quite a bit less writing than we did on any of the substitution problems. So again, elimination tends to be the one most people prefer when you get a choice. So 5 times -2 would be -10. 3 times 4 is 12. -10 plus 12 is 2. 2 times -2 is -4. -4 times 4 is -16. -4 minus 16 is -20. Remember? Chad, you're okay? Kenzie? Brooklyn? All right, last thing, the special cases. So we talked on Friday about the graphing side of things. That what we're looking for here. We're graphing one of these lines. We're graphing the other line. We're looking for that place where they cross. Okay, that's what we saw on Friday. And with curves, we can have them cross multiple times. With lines, they can only cross once. Okay, but the other instance here is, well, what if they don't cross? All right, what if they're parallel? So if they're not crossing, that means they have no solutions. And then the last thing that could possibly be happening is, what if they're the same line? All right. And then we talked about that very briefly Friday, that would mean that there's infinite points of contact, infinite solutions. So that's what the special cases are, the no solutions, the infinite solutions. So how does that, that's how it looks graphically. How does it appear algebraically? Like, what do we see that tells us that there's no answers or that there's infinite answers? So versus one answer. There's one answer to this problem. There's one answer to this problem. There's no answers here. There's infinite answers here. What does it look like? So here's the real thing, right? What's the problem telling us? What's the problem showing us? It's saying, hey, let's do this, or hey, let's do this. And how do you start making those decisions? So what do you guys see here in number 5 that's saying, let's do substitution or let's do elimination? How's it talking to you? What do you see, Lucas? Okay, both in standard form. Okay. Okay, so Lucas is saying they're both in standard form. They're already lined up. And then if we multiplied this by 3, we'd have the opposite coefficients there. Okay, that's what he's saying to do elimination method. Okay, so sure, that's probably what I would do. So let's hit that bottom equation by 3. Oops, I don't know, I did that twice. Generally easiest if you just go ahead and rewrite both of them. And there's a reason there's special cases, because right now you should notice something that's happening that's special. I can't hear you, sorry. Yeah, right? Those cancel, gives you 0. Those cancel, gives you 0. So 0 plus 0, right? And those cancel, give you 0. And does 0 equal 0?
Yeah.
Sure does, yeah. And 0 always equals 0. And that's a true statement. 0 does equal 0. And it doesn't matter if it says, 3 equals 3. It doesn't matter if it says negative 11 equals negative 11. Those are all true statements. Okay, so what matters here is that the variables all cancel. Right? We don't have any variables anymore. So x doesn't equal 0, y doesn't equal 0. They're just always true. Right? They canceled out and you end up with this true statement. Well, these two lines here are always touching. Okay? And the purple line and the red line only touch sometimes, once, right? Because there's one answer. These are always touching. So when you end up with this true statement, it doesn't matter what the numbers are, as long as it's true, that's an infinite solution. So it's the interpretation of the answer that really matters here, guys. All right? Because we don't actually get an answer. Okay? What we find out is that there will always be answers. So you would need to interpret that to say, okay, there's infinite solutions. But what you don't want to do is say, well, okay, x must be 0 or something like that, or y must be 0, and then plug it back in and get the other variable and then go and check it. It's going to work, because it's going to work, right? But then you'd say there's only one answer, and there's a whole lot more than one answer. Okay? So you just got to make sure you're seeing that those all cancel. Okay? So it's about the interpretation there. Amaya, what do you think about number 6? Like, how's the problem talking to you? Would you want to do elimination or substitution? What you seeing? Okay. What do you want to substitute? So if we want to do substitution, we need one of the variables isolated. So which variable do you want to isolate? Kinda. Well, if we want x or y by itself, like x is almost by itself, right? It's not quite by itself. So what would we need to do to get x by itself? Definitely don't want to do that, because that would bring the y to the side by the x, right? And that would what's by this that we need to get rid of? So how would we get rid of that? Yeah, so definitely something we could do is just divide everything by -1. So we get positive 2y minus 8. Divided by -2. Where you at? Divide what by negative? Don't say the word it, Connor. Yeah, so Connor's asking if we could just divide this by -2. We certainly could. That divides easily. That divides easily. But yeah, we'd end up with a fraction here. But mathematically, we could do that, but we just don't want to mess around with fractions if we don't have to. So, yeah, that would be an option, but this would be an easier option. So what should we do with this 2y minus 8? Plug it in. Get into that first x. So 2 times. Or it'd be wrong to plug it into the x in the second equation. It has to be the first one. If you plug it into the x in the second equation, you're just going to end up with this loop that gets you nowhere. 4y minus 16 minus 4y equals 5. Henry, what do you notice there? Okay, what are they going to do? So yeah, we combine the 4y's on that left side. They cancel, so we're just left with negative 16 equals 5. Does negative 16 equal 5? Or doesn't, right? So there's a false statement. Right?
That doesn't mean we did it wrong.
No, not necessarily. I mean, you certainly could have made a mistake, but yeah, that's the tricky thing about the no solutions and infinite solutions is that you could make a mistake and lead yourself into thinking there are no answers. It's pretty hard to, you can't check because there's nothing to check. Like you're saying there's no answers. There's no answers to check. So really the only thing you can do is go back and look over your math jet and make sure you didn't screw something up. So yeah, that could be definitely a trick here that you could fall into. So, what are we looking at here, right? Things that don't touch, right? There is no, so we're looking at those parallel line type situations. So there's just no solutions here. So again, it doesn't matter if it's negative 16 equals 5. It doesn't matter if it's, 0 equals 3. If it's negative 2 equals 2. If the numbers aren't the same, then that's a false statement. They have to be exactly the same. And so the interpretation there is there are no solutions. So the special cases, right, what do? What's different about them? The variables all cancel. You're left with either this true statement or a false statement. And then it's up to you to interpret that statement. Okay? So if everything cancels as far as the variables, then you need to interpret it. Otherwise, you're going to be left with a value, right? X equals 6, y equals negative 4. You can't do that here. All right. Let me stop this real quick and I'll point some out to you guys.